Writing code takes a lot of time, and sometimes you want to put the immense power of the computer to its best use. One of the most important control structures within computer science is the loop, which lets you repeat lines of code within your program. The basic structure of a loop is you start with a test, very similar to an if statement. The thing about this test is it's going to get checked every time the loop runs. So you put a test at the top, some amount of statements inside that you want to repeat, and then after each time the loop runs, or what we call an iteration, the code's going to come back to your initial test and say, hey, should I run again? And if so, it will repeat on and on and on until you've decided that that test should return false. So all of this is still based on a Boolean value, true or false. While it's still true, keep going. If it's false, stop, and then you move on after the loop to the rest of the code in your program. The simplest form of a loop is called a while loop. So I want to do something while this test is true. You start with the keyword while, and then in parentheses, a Boolean expression that evaluates to true or false, and then a set of curly braces in your statements. A while loop can change how many times it runs with each run of the program, depending on what your test is. So for example, you could have a test while the user says keep playing, keep running your code. Or while I haven't counted yet to 10, keep counting. In order for the while loop to function, you have to make sure that whatever your test is based on is changing in the loop. If you forget that part, then what you're going to get is called an infinite loop, because if the test evaluates to true initially and then you never change any of the information, then the loop is going to run and run and run forever and ever until your program crashes. The other type of loop is called a for loop. A for loop runs for a specific number of times. The for loop needs a lot more information initially than the while loop, but that's because it sort of takes care of all of that variable management for you instead of you having to remember to do it inside of the loop. The for loop has three parts. It has a variable initialization, and this is your special variable just for your for loop. Then it has the test, and then it has the update. All of this is in what we call the for loop header. Traditionally, the for loop variable is an integer, and the integer traditionally starts at either 0 or 1, and then the test goes up until that number hits a certain threshold, and the update counts up by 1 each time. This way, you could very easily say start your loop at 1, go until your loop hits 10, and count up by 1 each time. This means you're going to run your loop 10 times. So a for loop is a really great one to use when you know exactly how many times you want your loop to run. Let's think through how this executes, because it can get a little tricky. The first time your code hits the for loop, it's going to make that variable. It's going to make that new variable I. I stands for iterator, so that's traditionally the variable name that we use, but you could put any variable name in there. Once it makes I only lives between the curly braces, just like any variable. Then it's going to test right away. Hey, is this test based on what I's current value is, true or false? If it's true, then it's going to go run all the lines of code between the curly braces. Then it's going to get to that very last closing curly brace. It's going to come back up to the for loop header, and it's going to do the update. Now I has a totally new value, so it re-looks at the test. Is the test still true? Great, keep going. And it's going to keep doing that over and over again until finally that update makes it such that that test is false. Then the code finishes the loop and moves on to the line of code immediately following the curly brace. Play around with loops in different ways. You can count up, you can count down, you can go based on user input. It doesn't matter what test you pick. What matters is that you know you're testing something that's always changing, because you got to make sure that you're designing loops that eventually end. And sometimes you can have loops that run a very long time and make your code really slow. So learning how to use loops well and efficiently is going to make sure that your code runs exactly how you want it to.